Okay, question number 5 can be solved a lot of different ways. It says a function is shown, and that function is given by the equation f of x equals x squared plus 2x minus 3. All right, because of the fact that x is squared, we know this is a quadratic equation. And if you've studied quadratic equations, you know the graph will be a parabola. Okay, you may also know that because the coefficient of the x squared term is a positive 1, we can also conclude that this parabola will open up. It's not going to be an upside down parabola. It's going to be shaped like this. All right, so that's what I know immediately about this. Okay, there are a lot of different ways that we could find the x-intercepts and the maximum or minimum, which in this case, it's going to be a minimum because this graph opens up like it does. We want to plot those 3 specific points. So there's algebra that you could use to figure this out, but when you have access to technology, as you will during this test, I would absolutely go straight to the technology. So x squared plus 2x minus 3. All right, let's go back to our graphing calculator here and go to the expressions and reset this. So we want to type x, the x variable key, x squared, I forgot already, plus 2x minus 3. So x squared plus 2x minus 3. If you go immediately to the graph, what we see here is it looks to me like there's an x-intercept at positive 1 and at negative 3. And the minimum point down here, I'm going to guess, if I drop this down here, is down here at negative 1, negative 4. So using the technology, this is a very, very easy question. We want to put x-intercepts at negative 3 and positive 1. And then we want to put a point for the minimum at negative 1, negative 4, which is right here. And that is, I think, all you have to do for this, okay? Let me show you, for those of you that have the algebra behind this figured out, the other way that you can find x-intercepts, okay? The x-intercepts are the zeros of the function, okay? And they also then could be considered, the zeros are the solutions when the function equals 0. So this is some background knowledge, but you could totally solve it by using the technology and just move on. But let me just explain this. So if I take this function, f of x equals x squared plus 2x minus 3, and I set it equal to 0. In other words, I put a 0 right here. Then this is a quadratic equation that can be solved by factoring. Okay, we can factor x squared plus 2x minus 3 as a x plus 3 and x minus 1. All right, if I multiply that out, I get x squared minus 1x plus 3x minus 3. And so then I can use the zero product property and say x plus 3 must equal 0 or x minus 1 must equal 0. And so I get the x-intercept, or the zeros of the function, at x equals negative 3 and x equals positive 1, which is exactly what showed up when I used technology to graph this. All right. So the other piece of information that they asked for was the coordinate of the maximum or the minimum of the function. And if you've spent time working with quadratic equations and parabolas, then you know that you can find the axis of symmetry for that graph using the equation x equals the opposite of b over 2a. Okay, what the axis of symmetry is for the graph is it is the vertical line of symmetry, and it always passes through the minimum or maximum point, the vertex of the graph. So if we want to find that vertex, we can find the x-coordinate using x equals the opposite of b over 2 times a. Well, in my equation up here, a is 1, b is 2, and c is negative 3. And so if I take the opposite of 2 over 2 times the a value, which was 1, what I get is negative 2 over positive 2, or 1. Oops, negative 1. All right, so in other words, the x-coordinate of the vertex is negative 1. Okay, if that's the x-coordinate and I want to find the value of y, the y-coordinate that goes with that, then I can go ahead and say, use my equation. It says y equals x squared plus 2x minus 3. So let's go ahead and put negative 1 in for x. What is y when I put negative 1 in for x? And sure enough, what I end up with here is negative 1 squared is negative 1 times negative 1. So that's 1 plus 2 times negative 1. That's minus 2. And then my minus 3. And what I end up with here is y is equal to negative 4. And so, again, that verifies what I saw on the graph, that the vertex, which is the minimum point on the graph, is going to occur at the ordered pair negative 1, negative 4. So the algebra is a lot more complicated. Okay, you could solve this using algebra, but when you have access to the technology, use the technology.